Welcome to part 3 of chapter 8. This segment will talk about cold fronts and warm fronts and look at a little bit of violent weather. So the fourth and major part or type of rain producing event in the United States are fronts. You can have cold fronts and warm fronts, but a front is basically just this transition zone where one type of mass runs into another one. Keep in mind the cold air mass is always more dense than the warm air mass, and so whenever they meet, warm air for one reason or another will be lifted up above the other, and the warm air that is lifted has an opportunity to condense, create clouds, and perhaps rain. The leading edge, the front of a mass of cold air is called a cold front, and of course the leading edge of a warm air mass is called a warm front. That's actually taken from battlefield language from World War I. Here's how a cold air front works. Cold air moves into an area with warm air, and because it is denser, it holds closer to the ground. It forces warm air up abruptly. Oftentimes, if this warm air has plenty of moisture in it, that cold front will feature a line of thunderstorms, and then behind it, cold, clear air. This is what it looks like from satellite imagery. You can see a very distinct wall of cold air pushing into an area of warm, moist air. The clouds have great vertical development. Here's a little animation that shows how this works from a side view. Cold air moving into an area previously dominated by warm, perhaps moist air, forcing the warm, moist air up. Thunder clouds, cumulonimbus clouds, form at the leading edge of the cold front. In the rear of the cold front, once the cold air has established its dominance, clear, cold weather. A warm front operates slightly differently. Again, the front is the leading edge of the moving body of air. In this instance, the air is warm. Cold air remains stuck to the ground because it's denser. At the very leading edge of the cold front is way over here. High wispy cirrus clouds are visible for days in advance. If you're standing here, you will see them while the air is generally clear and cool, but over the course of several days, cirrostratus clouds, then altostratus, and then stratus clouds will develop. Eventually, you'll get a layer of nimbostratus clouds, and rain may fall, sometimes slowly over a course of days. Here's a quick animation of how this looks. This is the first day. You're standing perhaps here, witnessing the cirrus clouds. Rain is falling at the front, but it's a gentle rain with low, thick, dark clouds. And after the front passes, it will be warm and dry. But these fronts don't move across the land in a straight line. It may seem that way to the person standing on the ground, but viewed from above, we see that these fronts tend to operate in great spiraling motions, and that the leading edge, the front, would be curved. Here's another animation. At the beginning of this series of slides, what you have is a cold air mass coming in. Violent thunderstorms may be occurring along this leading cold edge with the blue triangles. A gentle, more lingering rainfall may be falling on the leading edge of the warm front. The cold front will eventually overtake the warm front. Vast amounts of rain may fall here in what appears to be Arkansas and Louisiana over a period of days, and then a very violent thunderstorm may follow close behind. Flooding might be possible here. And at this point, we're beginning to see what is the development of an occluded front. This area here on the map is the occluded front, where the warm air is being lifted completely up above the cold air mass, and the rain may last for many days as this warm air mass is eventually stripped of all of its precipitation. This graphic shows what an occluded front actually looks like. These kind of storms, along with the convectional thunderstorms that we looked at earlier, can produce quite violent weather. In the wintertime, they may be blizzards or ice storms. In the summertime, more often thunderstorms. Particularly in the spring, tornadoes are possible, and through much of the late summer, hurricanes are possible along the coastal areas. We will examine each of these one at a time. Quickly, ice storms are winter storms that feature freezing rain, sometimes sleet, which is a type of frozen rain that comes down, as opposed to rain that lands as water and then freezes. Keep in mind that neither of these are the same as hail, which is generally only happens in the summertime. Blizzards are winter storms marked by high winds and blowing snow that reduce visibility to sometimes near zero. And that's the characteristic of a blizzard, is the snow and the high winds. This is a photo I took in 1998 after a massive freezing rainstorm, northern New York and southern Canada near Ontario. Note in this photo that I took how many of the trees are broken off at, 20, 30 feet in the air. This one's a little further higher up. Almost all of these trees were killed. Thousands of people lost power for a long time because this freezing rain also snapped off telephone poles, power transmission lines. Thunderstorms largely happen in the summertime. They can be produced both by frontal cyclones and by convectional effects. Those are frequently called pop-up thunderstorms. They happen in Florida and over the Midwest. Thunderstorms have lots of precipitation, sometimes lightning, thunder, occasionally hail, strong winds, and maybe even tornadoes. Here's a map of thunderstorm frequency in the United States. Far and away, Florida leads the United States in thunderstorm frequency. People who go to Disneyland often remark, "Hey, I thought I was going to sunny Florida, but it rained very hard every afternoon." And that frequently will happen. 100 out of 365 days a year, they will have a thunderstorm just in central Florida. Angeles, 5 to 10 a year in a good year. One of the main differences between Los Angeles and Florida is the temperature of the water off the coast. The water here is quite warm, can be over 85 degrees. Rarely does the water off the coast of California get above even 60 degrees, and so there's a lot less energy to fuel thunderstorms. Here's a photo of a hailstone that I collected at my house years ago. These fell in my yard onto my car, dented it quite badly. Luckily, none fell as large as this, which was a few years after I took my photo. These kind of hailstones can bust through the window of an automobile, leave huge dents, strip fields of any crop of all their leaves, create enormous damage, and cost insurance companies millions of dollars. And they can kill you if they hit you in the head and you're outside. Los Angeles is not immune to hailstorms. This was from about 2003. These hailstones were not large, but they fell in such quantities that these images appear to be snowstorms. But these were summertime hailstorms down in South LA and Watts. Children ran into the streets, made snowballs in the middle of summer, and they had to bring snowplow type equipment out to clear the roads. Tornadoes are a source of fascination. Here's an image of a supercell, which is a huge thunderstorm, and a tornado is developing out of the very bottom of this. This wall of clouds can reach up to 30,000 feet or more. Here's a graphic that shows how a tornado develops. I have provided YouTube videos offer a better explanation than these static graphics, so I encourage you to watch those closely, take some notes, because you can expect a question or two about tornadoes and tornado development. Most of the tornadoes occur in the United States in what is called Tornado Alley, here the Central Plains states, focused on Oklahoma, and that's because there is a frequent clash, especially during the spring, between warm air coming up out of the Gulf of Mexico and cold air that has come down out of Canada, that continental polar. The most common month for tornadoes are May and June, and the destruction can be significant. A very large tornado on the EF scale, an F5 or an EF5, can not only rip a house from its foundation, but can pull the sidewalks clear out of the ground. Tropical cyclones, what we call hurricanes in the United States, develop just north or just south of the equator, but do not develop over the equator itself. Hurricanes are called typhoons by the Chinese, Japanese, and the Philippines, and they're called cyclones by the Australians, Indonesians, and Indians. They require warm ocean water and the atmosphere above it to get saturated with air, and that the warmer the ocean and the atmosphere, the more powerful the storm is. There are different levels, and they grow in size. They take on different names, from a tropical disturbance to a tropical depression to a tropical storm, and they are designated by their wind speed largely. A hurricane can reach wind speeds of 74 miles an hour or over 100 kilometers per hour. Once again, the static graphics are not nearly as good as a video of these development, so I have put YouTube videos online for you to watch. Make sure you take a look at them. More static videos, but here is a hurricane from above. Make sure you understand that spot in the middle is the eye of the hurricane, and it will have enormously low pressure, but the outer edge of that eye is called the eye wall, and the wind speeds are extremely high, and the amount of precipitation falling from the eye wall is also extremely high. This is a side view of the eye and the eye wall. This is a graphic showing where the tracks of the storm, where they develop. And again, this is about 20 degrees north or south of the equator, or between the tropics and the equator. Hurricanes that affect the eastern United States track along here. Violent typhoons track out of the warm water in the western Pacific and may make landfall in China or along Southeast Asia. Occasionally these cyclones also form in the Indian Ocean, occasionally making landfall in the Indian subcontinent, occasionally affecting Australia, occasionally hitting Madagascar. This graphic down here shows the wind speeds and tracks of a number of cyclones that have hit over the years. Notice that although we are here in the United States well versed with hurricanes, typhoons are more common and more deadly over in the far western Pacific. The most famous of all hurricanes is Hurricane Katrina, the one that hit in 2005 the city of New Orleans. About 2,000 people lost their lives in the hurricane, but it's the flooding that frequently kills more people. Sometimes the flood is part of a storm surge as the hurricane makes landfall, and sometimes it's from the rains that fall and come back down the rivers or just overwhelm the storm system. This is a photo of what happened here. There were levee breaches along Lake Pontchartrain, and the city filled with water in many of the lower, especially the poorer parts of town. Many parts have never recovered to this day. Here's a summary of Chapter 8. Make sure you take a look at these for the midterm.